What is up, math superstars? In this edition of Mr. Peterson Presents, we are now bringing to you two-step equations. So with two-step equations, we're going to figure out that it takes 2 steps to solve an equation that has more than one operation. And so in order to do this, we have 2 steps at the bottom right here. Step 1 is that we're going to simplify using the inverse of addition or subtraction. And then we're also going to simplify further by using the inverse of multiplication or division. And so, little reminder here about inverse operations. We know that if we are dealing with addition, that we need to subtract from both sides. And you notice that the arrow goes both ways. So if you have subtraction, the inverse of subtraction is addition. And then if you're dealing with multiplication, multiply, we know that we should divide both sides of the equation here, and it also goes both ways. So now let's take a look at these examples. We have 2x minus 5 equals 11. And so here is a prime candidate for two-step equations. So what we're going to do is let's take care of the subtraction first. Here, we're not going to divide both sides yet, but let's deal with subtraction to make our lives easier. So the inverse of negative 5 is positive 5. So let's do that to both sides. So then I'm going to bring down my 2x this time, bring down my equal sign, and I have 11 plus 5 is 16. So now we need to get x by itself, and there's 2 x's. So what we're going to do is let's go ahead and divide both sides by 2. On the left side, the 2's cancel out to leave me with x. Bring down my equal sign one more time. And then I have 16 divided by 2 gives me 8. What I can do to double check my work is I can fill it in for x. So if I do 2 times 8 gives me 16. 16 minus 5 gives me 11, so I know that this answer checks out. What about this example? Here I have 67 equals 11n plus 1. And so you have to show 2 steps in isolating your variable here. So I know that I'm going to do plus 1 to both, plus 1 on the right side, so let's go ahead and subtract 1 from both sides of my equation. I'm going to bring down my 11n, bring down my equal sign, and I have 67 minus 1 is 66. So here's my first step. But n is not by itself yet. There's 11n, so let's go ahead and divide both sides by 11. So on the right side, my 11's cancel out to leave me just with n being equal to 6. What I can do is to double check my work. If I fill in 6 for n, I have 11 times 6 is 66, plus 1 gives me 67. So to know that my work checks out. And you might say, Mr. Peterson, I did this in my head. This is called two-step equations. So the deal is you have to show me both steps in order to get the variable by itself. So what about this one? I have 7 equals 4 minus 2y here, and so let's go ahead and take a look at what we have to do here. So I have 4 on the right side. So since this is positive 4, I'm going to go ahead and subtract 4 from both sides of my equation. I'm going to bring down negative 2y, bring down my equal sign. Then 7 minus 4 is going to give me 3. Next step is that I'm going to divide both sides. Since I don't have y by itself, I have negative 2y. Let's go and divide both sides by negative 2. And that's going to leave me with y being equal to negative 3 halves. And you might go, negative 3 halves? Does that work? So if I filled in for y, I'm left with this whole thing being negative 3. So if I was going to write this out, 4 minus, and then a negative 3 is the total of 2 times negative 3 over 2. And then if I add the opposite, the right side does equal 7. So I know I did my work correctly. So what about this one? This one has a star next to it because this is an example here of when you do multiplication first. So you notice on the left side here, I have a fraction bar. Let's go ahead now and in order to simplify this to get x by itself, we're going to multiply both sides by the denominator first of 5. What this is going to do is that my 5's cancel out. So I'm going to bring all of this down. So I'm going to bring x plus 2 down, bring down my equal sign, and then 4 times 5 gives me 20. So there is my first step. Second step in this case is I'm going to subtract both sides by 2, where it leaves me just with x being equal to 18. If I'm going to simplify that, if I'm going to check my work, I put in 18 for x, 18 plus 2 is 20, 20 divided by 5 gives me 4. And so my work checks out. So this is one of the cases where instead of subtracting or adding first, you would divide, you would multiply both sides since I have division first. So here's another case. So for this one, you can solve this 2 ways. You can do the distributive property. So you can do 3 times x minus 3 times 2 gives me 6. But in this case, there's something unique that I can do with this problem. What I can do is I can go ahead and divide both sides by 3. So in this case, what I can, since I'm doing this, the 3's cancel out on the left side, leaving me with x minus 2 is equal to 4/3. And so this is a special case. Since I have multiplication, I can do the inverse of multiplication, which is division first. And so since I still don't have x by itself yet, let's go ahead and add 2 to both sides. So I'm left with x. Bring down the x, bring down the equal sign. And then I have, let's make common denominators. So I have 6/3 plus 4/3 is equal to 10/3 in this case. And so this is another example of where I can go ahead and since I have the multiplying by 3 first with the quantity x minus 2, I'm going to divide by 3 to make my life a little easier. If you didn't, and say you did the distributive property, you can start out with 3x minus 6 being equal to 4 and then kind of work from there. So if I did that one, I would add 6 to both sides. I would have 3x is equal to 10. And then I can go ahead and divide both sides by 3 to give me x equal to 10/3. And so you might go, wait, I like that second way a lot better because I didn't have to add the fractions together. You can do it either way. Just you have to show both steps in two-step equations.